Welcome to my YouTube channel. I am Deepak Bhatta, an assistant professor from the Department of CSIT at Kailali Multiple Campus, Dhangadi, Kailali. So let's dive into the exam question, which is explain the degree of tree, depth of tree, m-ary tree and full m-ary tree, and also asks in the tail part, prove that a full m-ary tree with I internal vertices contain n equals to mi plus 1 vertices. So before starting the degree of tree, we have to learn about the tree. What is tree? So tree consists root node and internal node and leaf node. So this A is the root node and A has two children B and C. So these B and C are the parents or internal leaf node, and B has also three children D, E, F. So here D is the leaf node. So leaf node are those nodes which do not have any further childrens. So E is also a leaf node, but F is not a leaf node. This is a internal node because F has the one node which is H. So we can call this F as an internal and H as a leaf node. So likewise G is also a leaf node which do not have any further children. So this is the simple structure of a tree where we have root nodes, leaf nodes and the internal leaf or internal nodes. So let us explain the degree of a tree. What is degree of a tree? In the context of tree, the degree of a tree is typically understood as the maximum degree of any vertex in the tree. The degree of a vertex in the number of edges incident to it. The degree of a tree is the maximum degree of any node in the tree. So in the above example, the degree of tree is 3 because no node has more than 3 children. So here B, so from the B we have D, E and F. No node has more than 3 children. So the C has only one children, that is G. F has only one children, that is H. So A has two children, A, B and C. So you can observe this tree. So which node have the maximum number of children? So B has the maximum number of children, that are D, E, F, which is 3. So we can say that the degree of a tree, so degree of a tree is 3 because there is no more than 3 children. So this 3 is the maximum children. So we can call the degree of a tree is 3, right? Make the C as 4 children. Now the degree of a tree would be 4, right? So maximum children is 4, which have C. C has maximum children 1, 2 and 3 and 4. So we can call the degree of a tree of this graph is 4. So as per our given question, given example, we have only 3 children of B node. So we can call it as degree of tree is 3. So depth of a tree. So the depth or height of the tree is the is the length of the longest path from the root to any leaf. In other words, it is the number of edges on the longest path from the root to a leaf. The depth of a tree is the maximum depth of any node in the tree. The total number of edges from root to leaf is in the longest path. So we have to find the longest path from the root to any leaf node. So here in the above example, from root node, that is A to H. So here A to H, this is the longest path. So if I make it this from A to B, B to F, and F to S, this is the longest path. So count the number of edges. So A to B 1, B to F 1, and F to H 1. So 1, 2, and 3. So longest path from A to H is the depth of a tree. So depth of a tree would be 3, A, B, F, and H. So this is the depth of a tree. So now let us talk about what is m-ary tree. An m-ary tree is a tree in which every internal non-leaf vertex has no more than m children. So let us take an example. m-ary equals to 3. So that is 3 array tree, right? This is example. So make a root node, that is this is a root node and this is child, right, this, and no more than m children. So we have only 3 children but not 4 children, right? You can construct 3 children or 2 children or 1 children but not more than 3 children, because we have taken 3 array tree. So this can be valid, this can be valid, this can be valid, right? This can be valid, this can be valid. But if I make 4 children, then it is not a m-ary tree. For m-ary tree, every internal node has no more than m children. So this is invalid, right? So this is a this is a 3 array tree example. Right, so you need to construct it in exam. So after writing the definition of m-ary tree, you need to draw this tree, 3 array example. So now full m-ary tree. A full m-ary tree is a special type of m-ary tree where every internal vertex has exactly m children. So this means that there are no internal vertices with fewer than m children. So the above 3 array tree is not a full m-ary tree. So this is not a 3 array tree. So this is not a 3 array tree. Instead it is a 3 array tree, so not a full, okay, not a full 3 array tree. So for full 3 array tree, our internal vertex must have exactly m children. So no internal vertices with fewer than m children, right? So let us take the example. So this is one root, and so let us take 3 array tree example. So let us take 3 children, and there must have 3 children, 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 so there must have 3 children. So this is a full 3 array tree. So figure full 3 array tree. So this is the example of full array tree. So for in the exam, you need to write the definition of full m-ary tree, and you need to construct the example. Let's take a full 3 array tree, and you need to draw like this, right? So every internal vertex has exactly 3 children. So here you have 3 children, here you have 3 children, here you have 3 children, for this node you have 3 children, for this node you have 3 children, for this you have 3 children, like every node have exactly 3 children. So let us move on to the tail part of the given question. So which is proof that full m-ary tree with I internal vertices contains n equals to m into I plus 1 vertices. So let us assume I be the number of internal vertices and n be the total number of vertices in the tree. So let us take example to prove the given theorem. So that full m-ary tree, okay, so I need to construct full 3 array tree, right? So one node, root node, and these 3 are the child. Okay. So this is a full 3 array tree. So let us prove it that n equals to m into I plus 1. So here m equals to 3. So as we have assumed that there are 3 m-ary tree, so 3 m equals to 3. So I equals to I is the internal vertices. So I is the internal vertices. So this is internal vertices 1, 2, 3, 4 and 5. So there are total 5 internal vertices. So I equals to 5. Then n equals to m into I plus 1. So m is 3 into 5 plus 1. So 15 plus 1 equals to 16. So there are total 16 vertices in the given full 3 array tree. So this n value is 16. So total 16 vertices. So let us count. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So you can see here there are total 16 vertices in the given full 3 array tree. So in the exam you can assume any m-ary tree. So m can be your 3, you can assume 4. So if you take 4 array tree, then it would be complex for your exam. So for easiness you can take m equals to 3. So full 3 array tree would be your best for the exam. So here we can prove it by using this formula, n equals to m into I plus 1. So proved. So hence proved. Right. So this much for today. So hope you like this video. So please subscribe my channel, like, share and comment if you have any doubt. So I will put all the definition in the description. So from there you can take it and make a note of yourself. So in the exam mandatory draw the m-ary tree and full m-ary tree. Along with, to prove it, take a simple full array tree and using n equals to m into I plus 1 you can prove it. So thank you so much for watching my video. Thank you so much.